In question 3, you have a dot plot with population values, and part A says, what would you expect the distribution of a random sample of 10 from the population to look like? So if you chose 10 of those points at random, what would you expect it to look like? I would expect there to be more points between 80 and 90 than 55 to 65. Essentially, I would expect there to be more at the higher end than at the lower end. You would also expect all points to be between 55 and 91. If all of the population is between 55 and 91, then our sample should not be outside of that because there are no points to choose from that are outside of that range. B says random samples of different sizes that were selected from the population in part A are displayed below. So you have that picture of 5 different sample sizes and their dot plots that match. How did your answer to part A compare to the sample size of 10? Meaning, did the sample size of 10, that first dot plot, match up with what you said? Did you have more values between 80 and 90? Well, it looks like there's 6 values between 80 and 90 on that first dot plot, and no values between, maybe 2 values between 55 and 65. So were there more? My description did match the dot plot for the sample of 10 pretty closely. Part C says, Part C says, why is it reasonable to think that these samples could have come from the population? Meaning, why is it that those 5 that they show above came from that original dot plot? Why would they come from that? Each of these samples have more dots on the upper end of the number line also they all have a similar spread between the 50s and 90s. Meaning, most of our minimum points are somewhere in the 50s, and most of our larger points are in the 90s. D asks, what do you observe about the sample distributions as the size increases? So comparing the sample size of 10, that top dot plot, to the sample size of 50, what do you observe? I think the more points we use, the more closely our sample gets to our population.